Hello, students. You must have seen that reddish-brown, flaky layer on old iron gates, or maybe some tools left outside. We see it almost everywhere, right? Well, today we're going to understand the actual chemistry that is happening behind this very common observation. So let us start with a simple question. Just imagine you have a strong, shiny iron nail, completely new. Now, if you leave this nail outside in your garden for a few weeks, what happens? It turns into a weak, brittle, reddish-brown powder. Why? How can a strong metal just fall apart like this? The scientific reason for this is a process called corrosion. And in today's explainer, our goal is to understand exactly what corrosion is, why it happens, and how it works at the chemical level. Now, you might be thinking, Sir, why are we studying about just one rusty nail? Well, it's because this very same process is a huge multi-billion-dollar problem across the world. The bridges we use, the pipes that carry our water, even our cars, all of these are constantly being damaged by corrosion. So you see, understanding it is extremely important for engineering, for public safety, and also for the economy.
Okay, so let's get into the science now. To properly understand corrosion, we have to look very closely at a microscopic level. It's not just some simple surface reaction. What is actually happening is that a tiny destructive electrochemical cell forms automatically on the surface of the metal. Let's break down this definition. The word electrochemical tells us it involves both chemistry and a flow of electrons, just like in electricity. Oxidation, means the metal is losing its electrons. And the words uncontrolled and destructive tell us that this is a wasteful process that destroys the material, unlike a battery, which is useful. Here is a very good way to think about it. We use a lot of energy in big factories to extract pure metals from their ores. So we are basically forcing these metals into a high-energy, unstable state. Corrosion, then, is simply nature's way of reversing our work. It is the metal trying to go back to its natural, more stable, oxidized form, like iron ore. So, what is actually happening on the surface? When water and oxygen are present, one small spot on the iron's surface starts to act as an anode. Here, the iron atoms lose electrons, they get oxidized. At another spot nearby, which acts as the cathode, oxygen from the air gains these electrons. It gets reduced, and the electrons flow from the anode to the cathode, right through the metal itself. This completes a small circuit that starts eating away the metal. So for your examinations, this is the definition you must remember. Please note it down. Corrosion is the unwanted, spontaneous oxidation of a metal. And what are the two essential conditions? The presence of moisture, that is water, and the presence of oxygen. Both are required. Now look at this comparison. It is very useful for clearing your concepts. A galvanic cell, like in a battery, is useful. A corrosion cell is destructive. But the most important difference is the last point. In a battery, the anode and cathode are two different materials, isn't it? But in corrosion, the anode and the cathode are just two different spots on the very same piece of metal. This is a key point. Now, I want you to pay close attention here. A very common mistake is to think that rust is just some ugly coating on the surface. That is wrong, and it is a dangerous idea. Corrosion is an electrochemical process that goes deep inside the metal, making it weak from within. This can lead to complete structural failure. To help you remember this idea permanently, let's use a simple analogy. Let us imagine that corrosion is like a disease. But instead of attacking a living body, it is attacking a piece of metal. Let's see how this works. First, you have a healthy metal, which is strong. Then, the attackers come, oxygen and water. They find a weak point, which is the metal's own tendency to oxidize. The corrosion begins, and just like a disease, it spreads and gets faster, making the whole structure weak. And the final result is failure, just like how a disease can make an organism very weak. And this is exactly why this topic is in your syllabus. We are studying the mechanism of this disease so we can learn how to prevent it. It's just like in medicine. If you understand how a disease works, you can find a way to stop it. This knowledge helps us protect our bridges, our ships, and our pipelines. Okay, so we have understood the what and the why of corrosion. Now, let's look at the how. We are going to build a clear, step-by-step picture of the exact chemical reactions that take place when iron starts to rust. So, let us visualize this. Picture a single drop of water, maybe rainwater, that has landed on an iron sheet. This small drop of water is the location where our tiny electrochemical cell is going to form. So, step 1. A spot under this water drop will become the anode. At this anode, oxidation occurs. Solid iron atoms lose 2 electrons each, and they dissolve into the water as ferrous ions, or Fe2+ ions. The solid metal actually starts dissolving at this point. Now, what happens to the electrons which were released by the iron? They travel to another spot. This spot becomes the cathode. It is usually at the edge of the water drop where more oxygen is available from the air. Here, reduction takes place. Oxygen molecules use these electrons and react with water to form hydroxide ions or OH- ions. Now, this is the most crucial part to understand. How do the electrons get from the anode to the cathode? They travel through the solid iron itself. The metal acts like its own wire. This flow of electrons completes the circuit of our tiny electrochemical cell. Okay, and now the final step. The ferrous 2+ ions from the anode and the OH- ions from the cathode are now both present in the water drop. They move towards each other, they combine, and they are further oxidized by atmospheric oxygen. This forms hydrated iron 3 oxide, and this brittle, flaky substance is what we call rust. So, we have gone through the entire process. What is the main point to take away from all this? The main point is that corrosion is a complex electrochemical process, and the reason we studied it in such detail is very simple. Only if you understand how it happens, you can figure out how to prevent it. Let us do a quick recap. First, the core idea is that corrosion is basically a destructive electrochemical cell. Second, the best way to remember it is using the disease analogy, which requires both oxygen and water. And third, the process involves iron dissolving at the anode, oxygen getting reduced at the cathode, and the products combining to form rust. So my advice for your exams is this. If you can clearly remember these 3 things, the core idea, the disease analogy, and that mental picture of the water droplet on the iron surface, this entire topic of corrosion will become very, very easy for you to handle. So, now we understand this hidden enemy, this electrochemical disease. This brings us to a very logical next question. Now that we know how corrosion works, how can we fight it? How can we prevent it? Well, that is a topic for our next session. I hope this explainer was useful for you. Thank you.